Hi, my name is Daniela Lopez. I'm in calculus class, third hour, and this is my presentation of the chapter 2 of related rates. So this is our problem. A baseball diamond has the shape of a square with size 90 feet long. A player running from second to third base at a speed of 25 feet per second is 20 feet from third base. At what rate is the player's distance from home plate changing? So we know that this is going to create a triangle. So we're going to start by drawing two triangles. And the first one, we're going to set up our variables. So here we're going to have H, which is going to stand up for height, B for base, and L for length. So with the information that they give us on our problem, we know that H is going to be equal to 20 because he is 20 feet from third base. And we know that B is going to be equal to 90 because that's the length of each side of the diamond. So now we're going to use the Pythagorean theorem so that we can find the side that we're missing. So we're going to have 90 squared plus 20 squared equals L squared. So we're going to have that 8500 equals L squared. So the square root of 8500 equals L. So we're going to simplify that square root a little bit. So we're going to end up getting that 10 from the square root of 85 equals L. So now we find that value that we're missing. So our next step is going to be to set up an equation so that we can solve this problem. So in this case, we're going to have the Pythagorean theorem. So we have h squared plus b squared equals L squared. So we're going to take the derivative. So we're going to end up getting 2h h prime plus 2b b prime equals 2l l prime, because here we're gonna have quotient rule. So in the first one we drop the power, which is 2, so we put the 2 and then times h, and then we load the power, which is the exponent, which is going to be 1, and then times the derivative, which in this case the derivative of h is going to be h prime. And then we keep doing the same with the next variables. So something that we can notice in here is that B, which stands for base and is 90, we know that that variable is not going to change because the length of the size of the diamond is always going to be 90. So we can cancel that out. So now that we cancel that, we can see what variables we're going to need. So in this case, we're going to need h, we're going to need h prime, we're going to need l, and we're going to need l prime. So we know that h is equal to 20, as we can see on our little picture that we draw. We know that h prime is going to be equal to 25 because we know that the player is running from second to third base at a speed of 25 feet per second. And then we know that L is equal to 10 the square root of 85, and then L prime is what we're trying to solve for. So now that we have all of our variables and we have our equation, we just have to substitute so that we can find our answer. So what we can do in here, we can cancel this 2 from both sides. So then we're actually going to end up getting h prime equals L prime. So we're going to just substitute. So we're going to have h, which is 20, times h prime, which is 25, equals L, 10 is square root of 85, times L prime, so it's going to be L prime. So we're going to try to leave L prime by itself. So we're going to have 20 times 25 over 10 times a square root of 85. So what we can do in here, we can divide this by 10. So we're actually going to end up getting 2 times 25, which is going to be 50, and 1 times the square root of 85, which is going to be just 85. So our final answer is going to be that the player's distance from home plate is changing at a rate of 50 over the square root of 85 feet per second.